Now we are going to discuss about the applications of unit hydrograph to the construction of storm hydrograph resulting from the same unit duration. Here, just now we discussed about construction of unit hydrograph. For the construction of unit hydrograph, we should know the storm hydrograph, and from the storm hydrograph we separate the base flow, and after getting the separate the base flow, we get the direct run of ordinates, and then we calculate the direct run of depth, then calculate the unit hydrograph ordinates. Here this unit hydrograph is also used for the construction of again storm hydrograph. What is the necessary? What is the use? We got this unit hydrograph from the storm hydrograph. Why we are going to again for the construction of storm hydrograph by using this unit hydrograph? Yes, this is necessary. Why? That the intensity of rainfall is not constant. For example, already we solved one problem. There the intensity is different. For example, we have taken one intensity of rainfall. That, for example, the intensity of rainfall is 10 mm per hour. Corresponding 10 mm per hour intensity of rainfall, we have the ordinates of, that is discharge ordinates corresponding time, that storm hydrograph ordinates, right? So based on that storm hydrograph ordinates, only 10 centimeters, 10 mm per hour rainfall excess. Okay, so based on that we have prepared the unit hydrograph. But next we are going to instead of 10 mm per hour rainfall, 15 mm per hour rainfall. What is happening? The storm hydrograph ordinates are different, and direct run of ordinates are different, and calculated unit hydrograph ordinates are different. Then go to 20 mm per hour. That means rainfall intensity varies from time to time. So here once we have the unit hydrograph for one catchment area, that unit hydrograph can be used for the construction of storm hydrograph of same unit duration, but the intensity of rainfall varies is also applicable. For example, the rainfall excess one condition 3 centimeters, one pattern, and another time the rainfall excess 5 centimeters. Even 3 centimeter rainfall excess, same unit duration, this hydrograph can be used for the construction of storm hydrograph. Rainfall excess 5 centimeters, but same unit duration, this unit hydrograph can be used for the construction of storm hydrograph for the 5 centimeters rainfall excess. In some cases, the rainfall excess may be increased 20 centimeters, even though 20 centimeters of rainfall excess, but the unit duration is same of this unit hydrograph. Then also this unit hydrograph can be construction of used for the construction of storm hydrograph, because unit hydrograph is only one that is constructed from the storm hydrograph. This unit hydrograph can be used for the different storm hydrographs of different rainfall patterns, that mean different rainfall excesses. Right? Is it clear? Now, a unit hydrograph can be used to construct a flood hydrograph resulting from the rainfall of the same unit duration for which the unit hydrograph is available. Yes, we want to construct the 3-hour storm hydrograph. Right? 3-hour storm hydrograph we want to construct. Then go to office, then go to data collection place. What we are going to select? We are having 3 hours unit hydrograph or not. The 3 hours unit hydrograph is only used for the construction of 3 hour storm hydrograph. Right? Is it clear? Then a number of unit hydrographs for the given catchment is theoretically infinity. Yes. Here, any catchment area, the unit hydrographs are infinity. Number of unit hydrographs is possible theoretically for one catchment area. Why? Because the rainfall duration is varies from time to time. One time, for example, this is the catchment area. We are having 3 hours rainfall continuously. That is also effective rainfall. In some 3 days after, 1 month after, 1 year after, same catchment area having 6 hours rainfall excess, or another time 1 hour rainfall excess, and one more time 3 hour rainfall excess, one more time 24 hours rainfall excess duration we have. That means different rainfall excess are possible for every catchment area. So that rainfall excess varies. Rainfall excess varies means effective rainfall varies. Once effective rainfall varies, unit hydrograph varies. If the effective rainfall is 3 hours, we are going to prepare the 3 hours unit hydrograph. Effective rainfall 10 hours, we are going to construct the 10 hours unit hydrograph. Effective rainfall 1 hour we are going to construct the 1 hour unit hydrograph. That means theoretically speaking, number of unit hydrographs are possible for any catchment area. This is one way. Another way, if the unit duration is 3 hours, for example, unit duration is 3 hours, rainfall excess depth is 5 centimeters one time. Another time, unit duration, that means effective rainfall is 3 hours, but rainfall excess is 10 centimeters. Another time, this is common. Rainfall, unit duration is 3 hours, rainfall excess is 20 centimeters. Yes, with respect to duration is same, unit duration is same, effective rainfall is same, but intensity is different. Here also having different unit hydrographs. Because intensity varies, rainfall depth varies, automatical discharges varies, direct run of ordinates varies, once direct run of ordinates varies, direct run of depth varies, once direct run of depth varies, automatical unit hydrograph ordinates also varies. So that in a given catchment, theoretically speaking, number of unit hydrographs are possible because the intensity, effective rainfall varies time to time, and also intensity of rainfall also varies time to time. But one for every possible duration for rainfall and every possible duration pattern and basin. Practically only limited number of unit hydrographs can be for a given basin. But strictly speaking, for a given catchment area, our department, that irrigation department, meteorological department, or any professors and related, any possible persons are going to prepare the only 3 or 4 unit hydrographs for a particular catchment area based on the earlier rainfall data. For example, one catchment area, this is the Rajam, says one catchment area. Here by the old observations, the rainfall is, effective rainfall on a particular Rajam is 3 hours, one time. Another time 6 hours. One more another time 2 hours. 6 hours, 2 hours, 3 hours, 6 hours. After 1 year also almost all 2 hours, 3 hours, 6 hours. And one more time 1 hour. 1 hour, 2 hours, 3 hours, 6 hours. This is the type of rainfall, effective rainfall duration having in a particular area after observing some years, 10 to 15, 20, 100 years based on the earlier data. Okay. Here rainfall pattern is distributed like that, that is 1 hour effective rainfall one time, most probably 2 hours or 3 hours, 6 hours. This is the pattern of rainfall on a particular this catchment area. So that we think like that, okay, we are going to prepare the unit hydrographs for this area is 1 hour unit hydrograph, 2 hour unit hydrograph, 3 hour unit hydrograph, and 6 hours unit hydrograph. These are prepared based on that rainfall discharges on a particular rain gauge station for that particular stream location. Only 4 unit hydrographs are prepared. These 4 unit hydrographs are prepared and stored one place. Then we are going to estimate the storm hydrograph. Because unit hydrographs are prepared for 4 different rainfall patterns, 4 different effective rainfalls. 4 unit hydrographs we have. Next time, having 1 hour effective rainfall in this Rajam catchment area. But intensity is 1 centimeter per hour. For 1 centimeter per hour, we are going to estimate the storm hydrograph by using the unit hydrograph. Another time, 1 hour effective rainfall duration, 3 centimeters rainfall depth. Then we are having 1 hour unit hydrograph, 1 hour rainfall pattern. Then go to construct the storm hydrograph for 2 centimeters rainfall depth, for 3 centimeters rainfall depth, 10 centimeter rainfall depth. But this only 1 hour unit hydrograph can be used for the different storm hydrographs, but the unit duration is 1 hour. And also we are having 3 hours unit hydrograph here. If the rainfall pattern is 3 hours, 3 hours rainfall pattern having different intensity of rainfalls. For that, we are going to prepare the limited number of unit hydrographs on a particular catchment. That unit hydrograph can be used for the storm hydrograph for any depth of rainfall excess. But unit duration is same of available unit hydrograph. The unit hydrograph selected for the corresponding, the flood hydrograph should be corresponding to the storm of like duration, that means same effective rainfall should be selected, then only possible to construction of storm hydrograph by using the unit hydrograph. That is very important. But intensity of rainfall, 3 centimeters rainfall access possible, 5 centimeters rainfall access possible, 1 centimeter rainfall access possible, but our existing unit hydrograph is 1 hour unit hydrograph. You should select the for the construction of storm hydrograph 1 hour duration. Right here, but strictly speaking, the 3 hours unit hydrograph should be used for the 3 hour storm hydrograph. But even though some cases we are having 1 hour unit hydrograph from the Rajam catchment area, 2 hours unit hydrograph Rajam catchment area, 3 hours, 6 hours. We are having only 4 unit hydrographs for this catchment area, but we want to construct the 7 hours storm hydrograph and 4 hours storm hydrograph, but we are not having that unit hydrographs here. Only we have 1, 2, 3 and 6 hours unit hydrographs. So even though that 4 hours, 7 hours unit, 4 hours, 5 hours, 7 hours unit hydrographs also, storm hydrographs also possible, construction of storm hydrographs also possible by using this available unit hydrograph, but having small error, but not completely having any problem to the construction of storm hydrograph. That can be applicable. That means here the tolerance of 25% of the unit hydrograph can be used for the construction of storm hydrograph, not much error. That means, for example, we are having 6 hours unit hydrograph for the Nagavari basin or Vamsdara basin, having only one unit hydrograph, that is 6 hours. This 6 hours unit hydrograph can be used, strictly speaking, for the construction of 6 hours storm hydrograph. This is right. But even though some cases this can be applicable 25% more or less, not giving much error. So that 6 hours unit hydrograph can be used for the construction of 4.5 hour storm hydrograph and also 7.5 hour storm hydrograph. This is the tolerance, no problem. Okay, is it clear? Now we are going to construct what is the procedure used for the construction of the storm hydrograph. Here procedure means already we discussed earlier class for the construction of unit hydrograph. So we know the storm hydrograph, then that storm hydrograph separate the base flow. Once separate the base flow, that direct runoff ordinates equal to storm hydrograph minus base flow. We have the direct runoff ordinates that are in metric cube, that are the discharges. We want direct runoff depth. Then direct runoff depth can be calculated by using one formula, that is equal to 0.36 sum of that ordinates into time interval divided by area in square kilometers. That is the direct runoff depth. We know the direct runoff ordinates and also direct runoff depth. So based on these two values, we construct the unit hydrograph. Where we are going to construct the unit hydrograph? Unit hydrograph ordinates equal to direct runoff ordinates divided by direct runoff depth. We have ordinates of unit hydrograph. Here also same procedure for the construction of storm hydrograph with the available unit hydrograph ordinates. What we require, once we know the unit hydrograph required, based on this unit hydrograph required, back calculations based on the unit hydrograph ordinates, first we calculate the direct runoff ordinates. Once we calculate the direct runoff ordinates, also having the base flow, the sum of the direct runoff ordinates and base flow have the storm hydrograph ordinates. Back calculations only, same procedure. But here, first of all, we have the unit hydrograph ordinates, right? First of all, what we are going to calculate first? Direct runoff ordinates. Direct runoff ordinates equal to, we know the unit hydrograph ordinate into rainfall excess, that is n centimeters of rainfall excess. Direct runoff ordinates equal to ordinates of unit hydrograph into n centimeters of rainfall excess. That may be varies, 5 centimeters, 6 centimeters, 5 centimeters, 8 centimeters, 4 centimeters, whatever the rainfall excess, but the corresponding direct runoff ordinates we have. This is the formula for the construction of direct runoff ordinates. Then this direct runoff ordinates plus base flow, we have the storm hydrograph ordinates. Right? Is it clear? Then now we are going to solve one problem here. The rainfall excess is equal to 8 centimeters. So this is the date of rainfall equal to 22nd August. But however, these are the ordinates, unit hydrograph ordinates baseline. Oh, okay, here 6 hours, 9 hours, 12 hours, 15 hours. Here the spacing is 6 to 9 hours, 3 hours interval. 9 to 12 hour, that is 3 hours, 3 hours interval. Time interval equal to 3 hours. Corresponding ordinates of unit hydrograph. They have given only ordinates of unit hydrograph. We want to construct the ordinates of storm hydrograph or discharge ordinates. Ordinates of storm hydrograph or discharge ordinates. They have given ordinates of unit hydrograph. So we have ordinates of unit hydrograph. First of all, we are going to calculate the direct runoff ordinates. Yes, once we know the direct runoff ordinate, then go to further. Direct runoff ordinates equal to what is the formula? So here, these are the unit hydrograph ordinates into rainfall excess. What is the value they have given? Rainfall excess 8 centimeters. Right? Here, ordinate 0.00 into 8, we have 0. Ordinates of direct runoff is equal to 0 at the first case, and second case 0.12 into 8. 0.35 into 8, 2.5. Like that, here we have the direct runoff ordinates. These are the direct runoff ordinates calculated by using the unit hydrograph ordinates that are the for 8 centimeter rainfall excess. Right. Here peak discharge is unit hydrograph peak is 2.8 and corresponding direct runoff is equal to 22.4. Now we are going to estimate the storm hydrograph ordinates or discharge ordinates. Storm hydrograph ordinates is equal to equal to direct runoff ordinates plus base flow is the direct runoff ordinates. They have given directly base flow on a particular rainfall pattern. Base flow is equal to 4 meter cube per second, 3.5, like that they have given up to the last hour. These are the base flows. The sum of base flow and ordinates of direct runoff, we have the ordinates of storm hydrograph. This is the storm hydrograph ordinate. And again, one more example, if this is the unit hydrograph ordinates, if there is the rainfall excess is equal to 8 centimeters. And the same catchment area, but effective rainfall is same, but intensity is 15 centimeters. Even though we are going to construct the storm hydrograph using same procedure here, instead of 8 centimeters, you are going to use 15 centimeters. 15 into this one, you have direct runoff ordinate. 15 into this one, you have direct runoff ordinate. So these are the direct runoff ordinates for 15 centimeter rainfall excess, but unit duration is same, that is fixed. And again, corresponding, not these values base flows, corresponding 15 centimeter rainfall excess, we are having different base flows. So this base flows plus ordinates of direct runoff, again we have the different value of storm hydrograph ordinates. This is the procedure for the construction of storm hydrograph by using the unit hydrograph technique or by using the unit hydrograph readings. By using unit hydrograph with same unit duration, we are going to construct number of any type of rainfall excess available, then that storm hydrographs can be prepared. So now we are going to apply the unit hydrograph for the construction of storm hydrograph resulting from 2 or more periods of rainfall. Now we have discussed about construction of storm hydrograph by using the unit hydrograph for one rainfall excess, that is 8 centimeters. But here the rainfall, the unit hydrograph duration must be same as that of the storm hydrograph, whatever we are going to construct the storm hydrograph. But here the rainfall intensities, that means rainfall excess should be having different than 2 or more rainfall excess. How to construct the storm hydrograph by using the unit hydrograph here. Yes, another one, the essential condition that however is that the storm pattern should be same as that of the unit hydrograph pattern. That is the same. Only we are going to construct the storm hydrograph of different rainfall intensities, different rainfall excesses, but unit duration is same as unit hydrograph. Right here, this is the example. Like, let us say that the 3 hours unit hydrograph is available. Right. We are having only 3 hours unit hydrograph. Right. We are going to construct the storm hydrograph for 9 hours rainfall pattern. Yes, this is possible. What we are going to do first, that 9 hours rainfall pattern can be divided into 3 ways. 3 hours rainfall, effective rainfall, 3 hours effective rainfall, and 3 hours effective rainfall. Only we are going to construct the storm hydrograph of 3 hours pattern because we are having only 3 hours unit hydrograph. Is it clear? Right. Then, for example, we are having 9 hours rainfall on a particular catchment area. That is for Rajam catchment area, or Nagavali catchment area, or Vamsdar catchment area. The rainfall is falling on a particular catchment area continuously for 9 hours. But we are having only 3 hours unit hydrograph. And a 9 hours period, the rainfall intensities also varies from time to time. So that we are going to prepare only 3 hours storm hydrograph only. Further, what we are going to do here, out of 9 hours rainfall, the intensities are first 3 hours rainfall and 1 centimeter for 3 hours duration. For example, first 3 hours, 10 centimeters of rainfall for 3 hours duration. Next 3 hours, 15 centimeters of rainfall for 3 hours duration. Next 20 centimeters rainfall for 3 hours duration. That means intensities of varies. First 3 hours 5 centimeters, next 3 hours 10 centimeters, next 3 hours 15 centimeters. Yes, this is the rainfall pattern. And the storm is divided into 3 parts and for the same unit hydrograph. And finally added these 3 flood hydrographs, then finally you have the combined hydrograph. Right, this is the diagram. Once you see the figure carefully, this is the overall diagram of our storm hydrograph. First you see, this is the horizontal line, time. This is the discharges or flood ordinates. So we have here only unit hydrograph, 3 hours unit hydrograph, and also 3 hours rainfall intensity, first 3 hours rainfall intensity, second 3 hours rainfall intensity, third 3 hours rainfall intensity, totally 9 hours rainfall pattern on a particular catchment area. Right. Now what earlier we discussed, by construct the storm hydrograph for 3 hours. One storm hydrograph, next 3 hours storm hydrograph, next 3 hours storm hydrograph, combined these 3 having the total hydrograph. That means total storm hydrograph for the entire area. Like that here. So we are having only, you see, this is this line. This line is the unit hydrograph. We are having only 3 hours unit hydrograph. This is the 3 hours unit hydrograph. By 3 hours, by using the 3 hours unit hydrograph, we are going to only 3 hours storm hydrograph. How to construct the storm hydrograph, you know, because just now we are discussing about that. Right, this is the 3 hours storm hydrograph. This is the 3 hours storm hydrograph. This is the 3 hours unit hydrograph. This is the 3 hours storm hydrograph. The storm hydrograph represents total rainfall depth. This unit hydrograph represents 1 centimeter rainfall depth. That means runoff depth. That already earlier we discussed. And this is one storm hydrograph for first 3 hours. Then second one, 3 hours lag, because after 3 hours second rain. First 3 hours this is here. This is second 3 hours. This is also 3 hours unit hydrograph, not 6 hours unit hydrograph. This is also not 6 hours storm hydrograph. All are the 3 hours unit hydrograph as well as 3 hours storm hydrograph, but lagged by 3 hours. That's all. But here, this is also 3 hours unit hydrograph. We are having these ordinates, and also we have the second 3 hours rainfall depth. That is N1 centimeter for 3 hours. By using that N1 centimeters, first you calculate the direct runoff ordinates, then add the base flow, then you have the hydrograph ordinates of second 3 hours. And then last 3 hours storm hydrograph. This is the 3 hours unit hydrograph. This is the same. This 3 hours unit hydrograph, this 3 hours unit hydrograph, this 3 hours unit hydrograph are same. There is no changes. This is the 3 hours unit hydrograph, but this is the 3 hours storm hydrograph for the last 3 hours duration. Right? Here, because this storm hydrograph is different from storm hydrograph 2. The storm hydrograph 2 is different from storm hydrograph 1 because the intensity of rainfall is varies from 3 hours different rainfall, next 3 hours different rainfall, next 3 hours different rainfall. So here we have 3 different storm hydrographs. This is one storm hydrograph, this is another storm hydrograph, this is another storm hydrograph. Joining some of these 3 hydrographs, we are having combined hydrograph. This is the final hydrograph for the 9 hours storm duration. We are having only one unit hydrograph, that is only for 3 hours unit duration. By using 3 hours unit duration, we have constructed 9 hours duration rainfall is there. But the storm hydrograph also constructed for 9 hours rainfall by using 3 hours unit hydrograph. Right? This is the procedure, this is the graphical representation. Then you solve one problem. This is also one of the example problem right here. Find the ordinates of storm hydrograph resulting from a 3 hours storm with a rainfall of 3 hours storm with a rainfall of 2 centimeters, 6.75 centimeters and 3.75 centimeters during the subsequent 3 hours interval. That means first 3 hours rainfall depth. First 3 hours rainfall depth 2 centimeters. Next 3 hours rainfall depth 6.75 centimeters. Next 3 hours rainfall depth 3.75 centimeters. Totally the rainfall duration is 9 hours. But rainfall intensity, rainfall depths are varies. First 3 hours having different value, second 3 hours having different value, and third 3 hours also having different value. By using this, we are going to construct the storm hydrograph. During a subsequent 3 hours interval, this is a continuous flow. That is also one of the important point. The ordinates of unit hydrograph are given in following table. Right here they have given 3 hours unit hydrograph ordinates. These are the ordinates 0, 1, 10. These are the 3 hours unit hydrograph ordinates because the rainfall pattern is 3 hours separation here. They have given only 3 hours unit hydrograph ordinates. These are the pattern 3 hours, 6 hours, 9 hours, 12 hours. Here also the time interval equal to 3 to 6 hours, 3 hours time interval, 6 to 9, 3 hours time interval. Therefore, for this pattern, the time interval equal to 3 hours. Right? This is the given problem by using these values. Now we are going to construct the storm hydrograph for the total 9 hours period. So for the construction of storm hydrograph, by using the unit hydrograph, we should know some parameters. For the storm hydrograph, first we know the direct runoff ordinates and base flow ordinates. The sum of base flow ordinates and direct runoff ordinates gives the storm hydrograph ordinates. For the construction of storm hydrograph ordinates, we have one formula that is equal to storm hydrograph ordinates equal to unit hydrograph ordinates into rainfall excess. But they have not given directly rainfall excess here. They have given rainfall depth 2 centimeters, 6.75 centimeters, 3.75 centimeters. This is the rainfall, not rainfall excess. This is not direct runoff. This is not runoff value. This is the rainfall given here. Apart from that, what they have given here, assumed and initial losses are 5 centimeters. You know what are the initial losses. And also infiltration index 2.5 mm per hour. What is the infiltration index? You know that is the average rainfall infiltration capacity of the soil. This is denoted by pi, right? Infiltration index equal to average rainfall intensity is equal to 2.5 mm per hour, and base flow is given 10 cumex for the entire pattern. That base flow is common for entire pattern from 0 to 0. The entire area is 10 mm. Right here, first we are going to calculate what is the rainfall excess for the first 3 hours. What is the rainfall excess for the second 3 hours? And also what is the rainfall excess for the last 3 hours. Right here for the first 3 hours rainfall excess, the rainfall depth is 2 centimeters. 2 centimeters means 20 mm. Right, 20 mm is the rainfall on a particular catchment area within the first 3 hours. So what are the initial losses? 5 mm. That initial losses should be filled with the first rainfall pattern. But the soil is dry condition. Before this rain, there is no rainfall because the entire depressions and grass are free from water. Once having 3 centimeters, 2 centimeters of rainfall on a particular area, first fill all the initial losses, that is 5 mm. 20 mm minus 5 mm. And then what are the another one? 2.5 mm per hour. For 1 hour, 2.5 mm of water infiltrates into the ground. The rainfall period is 3 hours. 3 into 2.5, 7.5 mm of water entering into the ground for that rainfall period. 7.5 plus 5 mm initial losses. 5 plus 7.5, we have 12.5. These are the losses. Then what is the rainfall depth we have? 20 mm. 20 minus 12.5, we have the 7.5 mm is the only rainfall excess for the first 3 hours rain. That is 0.75 centimeters of rainfall excess we are having in the first 3 hours rainfall. And then second 3 hours rainfall, the rainfall depth is equal to 6.75 mm. So what are the initial losses? These 5 mm of initial losses are filled at the first 3 hours rainfall, because there is no deducted from this one, because the entire grass and depressions are filled with the first 3 hours rainfall. That 5 mm are filled with the first rainfall, because there is no need to deduct this value from the second 3 hours rainfall depth. Only the average rainfall infiltration, that is 2.5 mm per hour, this should be deducted. This 2.5 mm infiltration should be followed, continued for entire rainfall pattern. So that 2.5 into 3 hours second rainfall duration also 3 hours. So 2.5 into 3 equal to 7.5. That is deducted from the 67.5 mm. Then we have the 60 mm of rainfall excess, that is 6 centimeters. First rainfall, 3 hours rainfall, we have 0.75 centimeters rainfall. Second rainfall excess, here 6 centimeter rainfall excess. Like that, last 3 hours, 3.75 centimeters of the rainfall depth. Here also we are going to deduct only the that infiltration losses, that 2.5 into 3, that is 7.5. We have the 30 mm of rainfall, 3 centimeters of rainfall excess. So here first 3 hours rainfall, 0.75 centimeters rainfall excess, 6 centimeters rainfall excess, 3 centimeter rainfall excess. Yes, we have rainfall excess here. Then the direct runoff ordinates equal to unit hydrograph ordinates. They have given here unit hydrograph ordinates into rainfall excess for the first 3 hours, rainfall excess for the second 3 hours, rainfall excess for the third 3 hours. Then we have different storm hydrographs. These 3 storm hydrographs. Then we have the storm hydrograph for the next overall 9 hours rainfall duration. Right here, this is the problem. Solved problem here. So these are the pattern: 3 hours, 6 hours, 9 hours. This is given in the problem. So the time interval is equal to 3 hours. You know, these are the ordinates of unit hydrograph that are given earlier. That these are the ordinates. So here rainfall excess, just now we have calculated first 3 hours rainfall 0.75 rainfall excess, second 3 hours 6 centimeters rainfall excess, third 3 hours rainfall period 3 centimeters of rainfall excess. First we are going to construct the direct runoff ordinates for first storm, first 3 hours rainfall, direct runoff ordinates for the second one, direct runoff ordinates for the third one. So how you have calculated this one? Unit hydrograph ordinate direct runoff ordinates equal to unit hydrograph ordinate 0 into rainfall excess 0.750. Then second one, this is the first 3 hours duration direct runoff ordinates. Right here 110 into 0.75, this is the value. 365 into, only these are the first 3 hours rainfall, because this value into all unit hydrograph ordinates, so you have the direct runoff ordinates here. Then go to second 3 hours direct runoff ordinates, so 0 into 6 is equal to 0. This is started 3 hours lag from the starting, because this is 3 hours late rain, right? 0 and 110 into 6 is equal to 660. Like that, this is the rainfall excess for the second storm. This multiplied with the entire ordinates of unit hydrograph, then we are having the direct runoff ordinates. Then this is the third rainfall, third pattern. Here also in the third 3 hours, last 3 hours rainfall duration, we are having 3 hours rainfall excess. 3 into 0, we have 3. This is lagged by 6 hours. 3 hours from this one, 3 hours from this one, 6 hours. So here this is a 0. 3 into 0, 0, and 3 into 110, this is 330. Like that, we are going to calculate the for all the ordinates of unit hydrograph multiplied with 0.3. These are the direct runoff ordinates for the last 3 hours rainfall pattern. Then this is the direct runoff ordinate. We know the base flow that is given 10 metric cube for entire zone from starting to ending for in 3 zones. First 3 hours rainfall, second 3 hours rainfall, third 3 hours rainfall. Therefore, here first direct runoff ordinates plus this one. So because in the 3 cases we are having same base flow, so that first we are going to add these 3 direct runoff ordinates. These 3 direct runoff ordinates. This is 0, 0, 0, like this, 1, 2, 3. These 3 direct runoff ordinates is this is sum of the direct runoff ordinates for the 9 hours rainfall. Direct runoff ordinates plus base flow, we have the ordinates of storm or storm hydrograph or discharge ordinates. These are the direct runoff ordinates, and add the base flow, this one. So here finally we are having the ordinates of the storm hydrograph or discharge ordinates. So here what we learned here, 3 hours unit hydrograph can be used for the 3 hours storm hydrograph, for the preparation of 3 hours storm hydrograph.